If we were to ask the average person about influential figures in the development of artificial intelligence, chances are most would offer up names like Marvin Minsky, Alan Turing, or Elon Musk. But few would name an unassuming bearded man from ancient Greece who lived over 2,000 years ago. And yet, without the groundwork laid by this ancient philosopher, the digital revolution might not exist at all. For it was Aristotle who created the first logic system ever and laid the foundations for how humans and machines think. In fact, many of the most important concepts in modern AI are actually based directly on Aristotle's ideas, including some of the most cutting-edge techniques. We just don't often realize it. So here are 7 surprising ways that Aristotle helped build the future. At number 7, truth values. At the heart of any good argument is truth. If you want to convince someone of something, you need to be able to demonstrate that what you're saying is true. This might sound obvious, but it's a surprisingly difficult problem for computers. You see, before the advent of modern electronics, truth was more or less a human concern. Philosophers had been arguing about it for thousands of years, but it wasn't really something that computers needed to worry about. Once we started programming machines to perform increasingly complex tasks. However, things got complicated. For example, if we tell a computer that all dogs are mammals and then ask whether cats are mammals, it will correctly answer yes, because it's been programmed to make logical deductions. But what happens when we feed a computer data with exceptions? Like if we also told it that George Washington was a dog, a cat, a mammal, it would erroneously conclude that cats are dogs too. That's because traditional computer programming depends on a binary understanding of the world that doesn't account for exceptions or context. For a long time, programmers worked around this problem by adding layers of complexity until one day a team of AI researchers came across a simpler solution based on Aristotle as ideas. In the mid-1990s, Drew McDermott and his colleagues at Yale University developed what became known as the Yale Shooting Script, an AI program capable of simulating human-like reasoning. The secret behind its success was assigning truth values to statements that accounted for degrees of certainty. Like instead of simply outputting yes or no answers, the program would assign percentages ranging from 0 to 100, reflecting how sure it was of its conclusions. This approach proved so effective that Google later adopted it for use in their search algorithms. And at number 6, syllogisms. But truth values weren't the only gift Aristotle gave to AI. His ideas about syllogisms have also proven invaluable to modern techniques. A syllogism is a type of logical argument that applies deductive reasoning to arrive at a conclusion based on 2 or more propositions that are asserted or assumed to be true. For example, all men are mortal. Socrates is a man. Therefore, Socrates is mortal. Because the conclusion follows necessarily from the premises, this is called a valid argument. By contrast, if we change the first premise to all bachelors are married, George is a bachelor, therefore George is married, we arrive at an invalid argument. In this case, the conclusion does not necessarily follow from the premises. Aristotle identified 3 different types of syllogisms, each with their own rules for validity, which remain fundamental to legal and mathematical reasoning today. And these rules are now built into the logic circuits that drive many modern AI programs, helping them reach valid conclusions from given premises. Number 5, categories. Back in the days of ancient Greece, there were very few, if any, formal systems of education. So people who wanted to learn would simply apprentice themselves to a philosopher for many years, absorbing their knowledge through lectures and discussions. This is how young Alexander, who would later become Alexander the Great, learned philosophy from Aristotle for 12 years. But there was a problem. There were just too many topics to cover. Even if Aristotle lectured for 8 hours a day every day for a year straight, there was still way more knowledge to transmit. So to solve this problem, he did something brilliant. He created a system for organizing knowledge into categories. He developed a list of 10 broad subject areas, things like substance, quantity, time, place, etc. Then he defined subcategories under each subject, such as the subcategory of substance would include things like animals, plants, and people, and under that, he would further define even more specific categories. This organizational structure was revolutionary at the time, and it remains incredibly useful today. For example, it forms the basis for library classification systems like the Dewey Decimal System and the Library of Congress. And it's also used in databases and search engines where keywords are organized into categories to help users find relevant information. At number 4, first cause argument. Not only did Aristotle organize existing knowledge into useful categories, he also made new discoveries. One of his most famous contributions was his theory of the 4 causes, a system for explaining the underlying reasons behind phenomena in the natural world. But while this was a huge leap forward at the time, it didn't quite capture the essence of causation. For example, if you break a vase, the material the vase was made out of is not a cause of the vase breaking. The real cause is your action. Aristotle realized this, but he didn't do much with it. However, in the early 20th century, this idea was picked up by philosopher and mathematician Alfred North Whitehead. Building on Aristotle's ideas, Whitehead proposed a radical theory. Every event, he argued, is caused by a prior event, creating a chain reaction stretching back through time. But this chain cannot stretch back infinitely. There must be a starting point, a first cause that sets everything else in motion. This argument, known as the cosmological argument, was a major inspiration for early AI researchers who were trying to create a machine capable of independent thought. They hoped that by understanding the first cause, they could unlock the secrets of intelligence itself. Unfortunately, they never quite succeeded. But the first cause argument has continued to influence the field. Today, researchers working on advanced AI systems are still trying to pin down the source of intelligence, whether it comes from genes, environment, or something else entirely. And number 3, scientific method. Of course, to understand the first cause, you need a system for testing ideas against reality. Otherwise, how would you know if your ideas were correct? It's a question that had never really occurred to humans until Aristotle. You see, until Aristotle, the pursuit of knowledge was largely a matter of intuition and authority. Philosophers accepted as true whatever made the most intuitive sense or was taught by someone they respected. But Aristotle rejected this approach in favor of a more systematic investigation of the natural world. He advocated for observation, experimentation, and logical deduction as a means of acquiring knowledge. This approach, which we now call the scientific method, was revolutionary at the time, and it continues to underpin modern AI research. For example, modern AI systems rely on large amounts of data to train their algorithms, and this data must be collected and analyzed in a systematic way. If not, the results will be unreliable at best and meaningless at worst. That's why scientists and engineers working on AI systems often spend months or even years simply gathering and cleaning data before any code is written. Without the scientific method, none of this would be possible. But it gets better with number 2, modality. The scientific method relies on reason and logic to uncover the truth. But sometimes the truth is right in front of us. Take this simple example. Imagine we have a block sitting on a table and we ask a child whether it will fall off. Any reasonable answer would be no. The block isn't moving and there's nothing to make it move. Therefore, it won't fall. But now imagine we remove the support underneath the table. The child's answer might change. They might say, "Oh, it will fall now." What happened? Logic hasn't changed. The block is still not moving. But the child has taken something else into consideration. Possibility. This is what's called modality, the ability to reason about the possible states of the world. And it's something that most people take for granted. But for a computer, it's a surprisingly difficult task. For example, consider the chessboard. A computer can easily calculate the best move by simply checking every possible variation and calculating the odds. But that becomes impossible in games with more options, like Go. To solve this problem, AI researchers are turning to Aristotle's ideas about modality. By defining a set of rules for reasoning about possibilities, they've built AI systems that can navigate complex decision trees and select the best course of action even in situations with countless potential outcomes. And at number 1, language. Finally, we get to Aristotle's greatest gift to modern AI, language. Thanks to the efforts of linguists and philosophers, we have a pretty good idea of how human language works. But that wasn't always the case. For most of history, people simply didn't think much about how language works. They just used it. But Aristotle changed that. He was one of the first to recognize that language is more than just a collection of words. It's a system for representing the world. He identified 10 basic categories of words, each corresponding to a different aspect of human experience. These categories, which included things like substance, quantity, and time, formed the basis for the world's first semantic network, a type of AI that uses knowledge about the meaning of words to understand and generate human language. Today, semantic networks are at the heart of many advanced AI systems, including those used for natural language processing. Well, there you have it, 7 surprising ways that Aristotle helped build the future. But before you go, we've got 2 more videos that we think you'll love. First up, we've got 7 surprising ways Pythagoras built the future, and second, check out 7 surprising ways Plato built the future. Thanks for watching, and we'll see you next time.